The Mesopotamians were said to have instigated the study of astronomy. In the 4th millennium BC, one of the most important observations made by the Mesopotamians was that they could predict the motion of the planets with a high degree of accuracy. The Egyptians were amazing sky watchers. They were so good they developed an amazing timekeeping system which led to a very sophisticated calendar that mapped skies using constellations and individual stars in 4000 BC. Edward Duke was the first person to connect astronomy and the Stonehenge. He described the Stonehenge as a platform full of significant astrological alignments. The British astronomer Sir Norman Lockyer said that the alignments implied a connection with sun worship.
The Chinese have records of astronomical observations that go back 4,000 years. Many objects and incidents were observed, written down, etc. China has studied astronomy continuously, longer than any civilization ever, during 16,000 BC. Notes of eclipses were transcribed on bones and shells. A lunar calendar was also in use by 12,000 BC. One was based on Jupiter and used animals. Gao Shaolin made the most miraculous gnome that tracked the movement of the sun, also made a star observatory.
Thales believed to be born in 625 BC. He was the first to start trying to explain the natural world without the use of a god, and he was the first to use the Little Dipper to measure pyramids by its shadow.
Pythagoras was the first to claim Earth was a sphere. He said that Earth was the center of everything. The Pythagorean view was simple but different. They said that all planets were in different spheres that rubbed against each other and made music. He said that Earth orbited fire because fire was very special to them. Babylonians used astronomy mainly for mathematical purposes, primarily in mathematical theory. A list of records that have survived include eclipse records and records of new moons. Instead of observation, they used math to predict current and future astronomical occurrences. Aristotle said that the Earth was a sphere because that was the perfect shape, said it was small compared to stars and always at rest compared to other celestial bodies. He was known as the grandfather of science, thought everything moved in circular motion because the circle was perfect.
Eratosthenes used math. He used difference in elevation of the sun at different times, and he was able to measure the angular difference between the vertical directions, which resulted in the circumference of the sun. Hipparchus' most important work involved the orbit of the sun and the moon and the size and distance from Earth. He assumed Earth was a spherical shape that was stationary in the center of the universe.
The Mayans thought astronomy was very important. This reflected the universe and the gods, thought time and dates were very important. Also that space and time were intertwined. They used the sky as a method of measuring passage of time. The Mayan calendars were one of the biggest advances that they made. The first calendar was called the calendar round, based on a 260-day sacred year and a 365 circular year. Urban Muslims were more accurate than Ptolemy. It blended Greek and Indian astronomy. Timekeeping was the main focus for prayer and pinpointing religious festivals. The Quran frequently talks about patterns in the sky and is a major source of Islamic astronomy. Longitude and latitude helped determine which way Mecca was. Copernicus was the first to say that all planets revolved around the sun and said that the setting of the sun and the movement of the stars and cycle of the seasons was caused by Earth's rotation. Brahe had some of the most accurate measurements that contradicted that the heavens never changed. Fred Hoyle is most remembered for his contribution to the theory of stellar nucleosynthesis. Penzias and Wilson in 1948 said we would see the glow of light that was released when atoms first formed about 3 million years ago. Armstrong and Aldrin were the first to walk on the moon.
Galileo observed 4 moons of Jupiter and showed that not all bodies orbit Earth. Newton was the first to say that all motions and objects on Earth could be described by 3 laws. The first law was objects at rest stay at rest. The second law was that the acceleration of an object produced by a net force is directly related to the magnitude of a force. The third law was for every action, there's an equal and opposite reaction. Started recording the celestial longitudes and latitudes of 341 stars and observed a transit of Mercury across the sun's disk. Albert Einstein determined that the laws of physics are the same for all non-accelerating observers and that the speed of light in a vacuum was independent of the motion of all observers. Determined that massive objects cause a distortion in space-time. Proposed a theory for the hydrogen atom based on quantum theory that energy is transferred only in certain well-defined quantities. Explained why atoms emitted light in fixed wavelengths. Introduced two new quantum numbers in the Pauli principle, stating that any two electrons in an atom cannot have identical sets of quantum numbers. Protons and neutrons in the nucleus were given quantum numbers, including the nuclei. Came up with the uncertainty principle, explains the impossibility of knowing exactly when something is and how fast it's moving.